All right, let's talk about one of the biggest questions out there. How does a machine actually learn? I mean, it sounds super complicated, right? All this talk about AI and neural networks, but what if I told you the whole idea, the very core of it, is as simple as walking down a hill? Seriously, stick with me and you'll see exactly how that works. Let's dive in. So let's just forget all the sci-fi stuff for a second. When we say a machine is learning, what are we even talking about? What's really happening under the hood that takes it from making totally random guesses to, actually getting things right? And believe it or not, the answer is this. It all comes down to one surprisingly simple rule: always walk downhill. That's it. That one single idea is going to be our guide for this whole explainer. Sounds almost too easy, right? Well, let's see how it actually works. Okay, section one, the goal, finding the bottom, returning errors into a landscape we can actually navigate. So, for this whole downhill journey thing to work, we need a landscape, right? But in the world of machine learning, this landscape isn't made of rock and dirt. Oh no, it's made of errors. Just imagine a huge valley, and the higher up you are on the hills, the more mistakes the machine is making. And what's so cool about this is how perfectly the technical self lines up with our metaphor. So on one hand, you've got the machine. Its goal is to minimize something called loss, which is really just a fancy word for error. And how does it do that? By tweaking an internal knob, a parameter that we'll call beta. Then you've got our metaphor, a hiker in a valley. Their goal? Get to the lowest point. And how do they do that? By taking steps. See the connection? The machine tweaking its parameter is exactly like our hiker taking a step. It's all about one thing: get to the bottom. So this is the really crucial part to get. The machine isn't thinking. It's not reasoning. It doesn't have feelings. It's just programmed with the single, almost obsessive goal: find the one spot anywhere in this huge landscape where its error, its loss, is as low as it can possibly go. Ideally, all the way down to zero.
All right, let's move on to our guide, the gradient. This is the one tool the machine uses to find its way. So, okay, the machine has its goal, right? Get to the bottom. But how does it know which way is bottom? It can't see the whole valley. For all intents and purposes, it's basically blind. It needs some kind of tool like a cane to feel the ground right where it's standing. And that tool is called the gradient.
Okay, so here's the technical bit, the definition of the gradient. All it is the slope of the hill at the exact spot where you're standing. Simple enough. But here's the catch, and you got to pay really close attention to this part. The gradient always points in the direction of the steepest increase. It tells you which way is up. And right there, in that one quote, is the entire secret. This is the big aha moment of this whole process. So think about it. If the gradient tells you the fastest way to go up the hill, what do you do if your goal is to go down? Well, you do the exact opposite. Yeah, it really is that simple. The machine just calculates which way is up, and then it takes a nice, confident step in the complete opposite direction. It's just a beautifully simple rule for finding your way downhill, even when you're completely in the dark. Okay, next up, 3 rules for the journey. We're going to see how the gradient gives the machine super simple commands, because this whole process can be broken down into 3 crystal clear rules. See, the gradient doesn't just point the way. It actually gives you a number, and based on whether that number is positive, negative, or 0, the machine knows exactly what to do next. And this table here, this is the entire playbook. So look, if the gradient is a positive number, that means the ground is sloping up to your right. So what do? You do the opposite. You take a step to the left, which means decreasing that beta parameter. Now, if the gradient is negative, well, that means the ground is sloping down to your right. Perfect. You just keep going that way. You take a step to the right, increasing the parameter. And the last one, the big one. What if the gradient is exactly 0? That means the ground is perfectly flat, you're at the bottom, you can stop, mission accomplished. So all of this comes together in something we call a learning loop. It's really simple when you break it down. Step 1, the machine measures the slope, the gradient. Step 2, it checks. Is it positive, negative, or 0? Step 3, it takes one small step in the right direction. And step 4, it just does it all over again, and again, and again. We're talking thousands, maybe even millions of times, just repeating this simple loop until it finally finds that perfectly flat spot at the bottom. And that, right there, that's learning. So now we're going to look beyond the hill, because this is just one of many paths to learning. Now, as powerful and as cool as this whole walking downhill thing is, it's really important to remember that it's not the only way a machine can learn. Think of this as just one amazing technique in a massive, massive toolbox that AI researchers get to play with. This specific walking downhill method, for example, is the engine that powers a super common model called linear regression. You've probably seen this before. Its whole job is to find the one perfect line that best fits through a scatter plot of data points. And now you know the secret. You know how it finds that perfect line. It's just walking downhill until its error is at rock bottom. But like I said, not all learning is about hills and valleys. You've got totally different approaches, like something called Bayesian classification, which has a completely different philosophy. Instead of feeling around for a slope, it thinks in terms of probabilities. It's all about weighing the evidence to make the most likely choice. It's a totally different path, but it's headed for the same destination, creating intelligence. And that leaves us with a pretty big final thought, right? We've just seen that a process that sounds as complex and mysterious as learning can actually be built from an incredibly simple loop of rules: measure, check, step, and repeat. So, if a machine can achieve so much just by blindly following this simple rule to always walk downhill, what does that say about the real limits of what can be learned?